Okay, let's continue. Services. Okay, so at the moment there's GSM, there's 3G and 4G. Okay, 5G is coming down the road, but we're not going to focus on that for now. So GSM is transmitted at 900 megahertz. It's actually also sometimes transmitted at 1800 megahertz, but let's just say it's transmitted at 900 megahertz. Obviously with GSM you got calls, but you don't have data. Okay. Sometimes they squeeze in edge data into the GSM, and we know that's absolutely rubbish. It's like you might get an email out or a text message. That's it. So then you've got 3G, otherwise known as H+. It's transmitted over 900 and 2100 megahertz. Okay. Yes, you can call over H+. The data speeds, they're okay. I typically see between 1 megabit per second and 10 megabits per second, typically. 4G, it's transmitted typically these frequencies here, 700, 800, 18 and 26. However, things are changing all the time. Now they're starting to put 4G carriers onto all the frequencies, including 900 megahertz and 2100 megahertz, okay? Because it's an efficient service, so the carriers want to use this instead. Up until a year or two ago, you used to not be able to make calls over 4G. Right? It used to be possible. So what would happen is you look at your phone, you see you got your 4G symbol on your phone, but when you make a call, it switches to 3G. Because typically you used to not be able to make calls over 4G. However, now that's all changing. So now all the modern phones, they have VoLTE, I think voice over LTE. And now you're starting to be able to make calls over 4G, so it's changing. 4G speeds are quite fast. So they're the services. So now we're going to talk about the frequencies. So a repeater system doesn't know anything about 4G, 3G, GSM. A repeater doesn't understand what the services are. All a repeater understands is the frequencies. Okay. So what are the frequencies? There are 6 frequencies currently. All right. There's these are the 6 frequencies: 700, 800, 900, 18, 21, 26. All right, they're the frequencies used all throughout Europe in every country. So what's the difference between these frequencies? Well, the lower frequencies, they propagate better in air and cable. They travel better across the land. They travel over mountains, through forests, through buildings. They're really good, okay? They're precious and they're really good. The problem is low bandwidth. There's a limited amount of users that can use these low frequencies. On the other hand, in the cities, they use all the frequencies, right? But these higher frequencies, I'm typically talking about these 3 here: high bandwidth, more users, right? Poor propagation. These high frequencies, they don't like to travel around buildings. They don't like traveling down the cable, okay? These high frequencies, they attenuate more in air and cable. Now in the city, what's going to happen is, if there's 2100 megahertz available or 2600 megahertz available, the operator is going to tell your phone to use those higher frequencies. It's always going to push you up onto the higher frequencies because it's there's more bandwidth available up there. Okay, that's something to be aware of as well. So for example, just to give you an example of an installation situation, you got a building, right? There's no repeater system. The repeater system switched off, and if you look at your phone, right, you use Network Cell Info Lite, which is, I'm going to bring it up and show you this. I have 3 phones here. Here's Network Cell Info Lite, just a standard phone. I'm on, which operator am I on? Post Mobile, and I can see the signal strength here, and I see I'm on band 3. It tells me the band as well, this phone is, okay? But band 3 I know is 1800 megahertz. So right now in this room there's 1800 megahertz. Okay, naturally existing in this room. My phone is connected to it. How about if I didn't know what I was doing and I decided, okay, I'm going to install a repeater system in this building, okay? And the repeater I install is an 800 and 900 megahertz repeater only. So what's going to happen? I install my repeater system, which amplifies 800, 900 megahertz. What's going to happen is all the phones are going to sit on this higher frequency, and they're not going to use the mobile repeater system. And the customers are going to complain. Let's say they were already complaining on their existing band 3. You see? Because the phones always use the highest frequency. So if band 3, 1800 megahertz already exists in the building, you need to cover it with your repeater. So you need to stick in a repeater system that also amplifies 1800 megahertz to cover this frequency. Okay, that's an important point. So range from the internal antennas. So the two types of installations you're going to encounter, and they're totally different, is the countryside and the city. Most of the time you're going to be in the countryside and rural locations, and that means that the range for those internal antennas is greater, okay? So here's some typical figures. If you're in a corridor, the distance between the dome antennas will be 30 meters. And what that means is you don't have to use as many antennas or as many line amplifiers. So the system's easier to install, it's cheaper to install. Okay. But if you look at the city, the distance halved. So that was 30 meters in the countryside. Now I'm in the middle of Paris, 15 meters. I have to shrink down everything, you know? I've got to put in more antennas now and more line amplifiers to get the system to work. Okay? Here's an example. I'm in the countryside. I'm able to put these omnidirectional antennas like this. Here I've got an omni antenna, and it passes through these wooden doors. And if those walls are made of plaster, the signal will just pass right through, no problem. Okay, if these are concrete block walls and metal doors, obviously the signal will not pass. But this is no problem, this works. I use let's say we use 7 antennas here. Let's say this same building was in the city. I'd have to do it differently. I'd have to put more antennas in the rooms, and then I like to put antennas out on the walls looking in like that. And the reason is I want to combat the natural signal that's coming in. So let's say I'm in this room, okay? There's a natural signal coming here. In a city, you're always going to have signals coming into the buildings, okay? City installations are difficult. Well, I want to make sure that my antenna's over there by the window so that my call is always going out through the antenna. If the antenna's here, and I'm in the room like this, I'm making a call, I'm going out over the antenna, that's okay, and then I walk over here, I'm walking over that window. At some point, the signal power from that window might be higher from that antenna, and I get a switch. And then that could end in a dropped call. So these concepts I'm talking about here are the most complicated things you're going to experience. You may never experience this, okay? And many installers never install in big cities, they don't see this. But in this course, I just want to make you a little bit familiar about this stuff, okay? This is how to do it properly, basically. Okay, so some test equipment. So this is Network Cell Info Lite here. So in actual fact, with just 3 or 4 phones with Network Cell Info Lite, you can actually gather a lot of information. You can gather the frequencies that are in the naturally existing in the building, the bands, and it can tell you a lot. What the signal's like in the roof. But for professional installations, you need to have a proper piece of test equipment. And we recommend Rohde & Schwarz, okay? But this is an expensive piece of equipment. You can get it for €4,000. That's how much it costs. But if you're serious about doing installations in big buildings, you need this. Okay? This basically will tell you pretty much everything you need to know. Okay, and it's what we recommend. Now, some customers they bulk at that price. It's very expensive. So we also have this one here, which is another type of analyzer. It's much cheaper. It's about $500. You plug it into your laptop, and it does give you the spectrum. But I have used this before myself, and the problem is it's not as accurate as this. It's not as easy to use, and you have to plug it into your laptop, and you got to carry your laptop around like this. It's not practical. It's cheap. It's not practical. If there was a way to somehow glue it onto your make it better, that may be okay. But I just find this is difficult to use. And we also use the iRepeater as a test equipment as well, okay, which is here, and I'll show you this, how we use it. This actually gives you a lot of information.